Righto, today we're going to do nothing to this AVO, this AVO 8, apart from, because it's all working, we're going to clean the switches, and I've shown you before how to do that, but we'll go through it again. And the most important thing of all, we're going to remove the meter movement and fully check it. I mean, in detail to the point of calibration. And if that's okay, once the meter movement's okay, then everything else falls into place with these anyway. So it's really just a case of getting this meter movement right, or in this case making sure it's right. Everything else in this, it all seems to work fine. Basic check, of course, is that it swings nicely, which it does, and if it's zeroed there, it's zeroed there. Those two things are fine, but we're going to take it out and we're going to make sure that it's got all of its deflection and that everything is working dead right with it. So some of these bits may be speeded up because they're just boring otherwise, and I'll just get on and pull this thing apart. I still haven't got my nut runner, so I'm still having to use trusty old pair of pliers to take it apart with. Right, let's see what we can do with it. Construction of these meters is very nice, and they have longevity built into them. I was not a complete idiot with it, but it will last your lifetime. It's a bit like my cutthroat razor. You know, you buy it once and you never have to buy another razor. I've actually got one of these meters that's missing one of these knobs. It's proving really difficult to find one. In fact, I can't find one, so I've ordered 4 different sorts of knobs, and I'm going to have to lay them down to make them fit on there, fit reasonable. I'm going to try and do this one without desoldering these boards, because no matter how careful you are desoldering them, this blue flexi PCB is not heat proof. I can probably show you that. Just touch it with an iron and it melts, and of course, no matter how careful you are, it makes a mess. So and there we have it. You're going to have to take the 10 amp or common terminal off here if you want to take the meter movement out. It goes into the automatic shutdown for protecting the meter movement, which is it works most of the time, but you can still damage the movement quite easily. any tools you use in a metal, give them a good wipe with a rag, because you don't want any little tiny bits of metal or iron filings here at all. It's just an absolute no-go area. And for that matter, of course, keep your bench clear of iron filings too. Once you've got iron filings in this meter movement, that is it. You know, it's harder than putting toothpaste back into a tube. It really is, to get rid of them. Okay, underneath these two brass screws, there should be 2 washers underneath here and 2 washers underneath there. Spring ones this end, big plain round ones that end. Okay, just take the big plain round ones off. And the little spring ones. Ooh, there's only one spring one on it. Must have run out of parts in the factory. We're going to be cleaning this pot, so we'll have that out as well. It's part of the ohm range. Zero in. Here's our meter movement. This is the other side of the coming in and out of the meter movement. It's just the circuit breaker basically. I'll show you that in more detail in a minute actually, because it's quite interesting. But there's one black wire just soldered to it, which is a grounding wire, so we're just going to nip that off and chuck this lot out. Who needs that lot? This is the bit that's important. Okay, what I like to do just screw the brass terminal in there. That way I can mount the meter movement, and it's easier to work on. That's all. Right, we can see it swaying around because, of course, the problem we've got now is that it's not in its environment where it's not really any air to it, any movement of air. I'll just put the knob to 0 and make it easier for putting it back together in a minute. So of course you touch it like this, and you know, well, you don't touch it, just a bit of wind, it's all over the place. Blow it hard enough and it should throw the trip out. This is the trip here. I'm gonna just move in a bit closer with this now so that we can see a little bit more detail. Blimey. Okay, is that all detailed? Yeah, I think so. So we'll just give that a quick blow and that will trip it, hopefully. There you go. It's tripped. Do it again. Same thing applies. Hold the needle over and blow it the other way. Like that. Trips in both directions. Well, I'll show you this trip. Before I do anything else, I'll show you this trip and we'll go over this meter movement. Okay, one of the most important things to check for, if you've got some, I always use cocktail sticks. They're just so good for doing any work on these meters, because they're obviously non-magnetic. Right, one of the things you've got to check for is that spring there, the actual one that holds the meter movement and also carries the current for the meter movement, is flat and even. And the same thing applies to it this end. So just take that cover off and make sure it's nice and flat and even. Sometimes when these things have had a big bang, the spring jumps over these balance poles. You've got a north, south, east and west balancing pole. The purpose of these balancing poles are well, exactly what they say, they're to keep the meter in balance. But if you've got a meter that's, for example, it gives you a nice zero, just stop this for a second, swaying, it gives you a nice zero that way, and then when you turn it up, it swings up or it swings down. Then you have to go to the back here, and if it's swinging up, which would be looking at the coil that way, anti-clockwise, then you would use the south balancing pole, which is like where it's got the wire wrapped around it and the glue on it, the south balancing pole, and put a very small amount of nail varnish on it, let it dry, because when it dries it gets lighter, and check it for zeroing. And that's all you have to do there. If it's doing it if it's doing it the other way, so it's going over below the zero mark, then instead of using which is the north south, use this one, which is the east west, and put a small amount of nail varnish here, and keep on messing around backwards and forwards until you're happy, until you get a nice balance on it. Right, I'm going to take this cover off this meter movement. This is a protective cover for the trip and the rest of the movement. These usually, the plastic crumbles on these, so just be aware and treat them with the respect that they deserve. And here we can now see, hopefully you can see, the trip mechanism, which is this mechanism here. Very, very light. So what we're going to do is reset the trip, and you'll see that goes forward like that, and then that black bar, I really am trying to make sure that you can see this, that black bar balances dead centre on this small pin, so that when the meter movement goes too far that way, it hits this and pushes it off that, pushes it off the centre of that pin, and it falls down into that hole. And if it goes the other way, it falls into that side of the pin. And when that happens, that breaks. In actual fact, it's only got to be 10 amps, but it's a lot more than that. It's this switch here. In actual fact, this switch is this protection part is broken, which I've seen before, because it's where the plastic degrades, and that will need to be replaced. If you can see that. Which is probably one of the reasons why the meter was I was told it was intermittent, but I never ever found a fault on it. I'm just taking these bits of broken plastic away. What a rotten thing to have happen, because you won't get another one of these. And basically that'll make this meter beyond repair. But having said that, of course, it'll be useful for spares. Hey, that means I've found my knobs that I needed, doesn't it? Right, there's all the plastics taken out of it, and a pain in the backside now. Still, never mind. I'll show you a couple of other things here whilst we're here. First of all, there's the reverse switch. That's just a straightforward toggle. It's nothing special. It's just a reverse. This is a thin winding that comes from the meter, tied in a little ball. The idea of it is it's a very, very low micro Henry coil. Really, it doesn't do anything. It's really, to be honest, this resistor here, I've had these fail. What they are, it's a it's a temperature compensation for the meter movement. It's as I say, it does exactly what it says on the label. It's compensation for the temperature, but I have had a couple of them fail. So when they fail, they go high, and when they go high, you can't get the right full scale deflection on the meter. It's a shame that this trip's buggered on this one, because it's actually got a very nice little movement on it. One of the things to check for these movements is that this gap here, this gap that I've put my cocktail stick in, is the same all the way around, because sometimes they get a whack and the magnets move, and that causes intermittent sticking of the meter. Whilst you've got it apart like this, take it sideways so you can, I'll put it this way so you can see it. I think you can, just about. And you should be able to lift that coil into the pin like that. I'll just put a bit of it, if I move it more central and move my light a bit, it's very difficult to see. Talk about such fine movements. This coil, the meter coil, should move forward, look there, into that pin. Likewise on this side of the meter, it should move forwards like that into that pin. That's, if you don't get that, if that's not balanced right, it should be so that those two springs hold it and there's play each side. And if you don't get that right, then you will get intermittent sticking on the scale, which nobody wants. Right. Now then, it's a shame. It is a shame. I could always bypass this trip. I can just use the meter myself, and quite frankly, very often you find that the damage is done by the time the trip goes anyway. But anyway, let's see how we get on. So we're going to bolt the meter down into a horizontal position, and I'm going to zoom out a little bit. Just can't get used to doing this camera lock. Okay. Make sure that the inverter is, the switch is just in. And we're just going to peel back a little bit on those two wires. And if you haven't got a separate resistor, get out your resistor substitution box and dial up 10k. Put that onto the negative side of the meter. Positive side goes to your power supply. Negative side goes back to your resistor substitution box. And just so that threw it alright, didn't it? But of course there's nothing protecting it. And all that was 5 volts with a 10k resistor in there. So I'm going to have to I just don't know. I just don't know what to do with this, to be honest with you. Wait until I get another meter or a cutout. There's certainly nothing I can do to repair it. I mean, it's just plastic's gone west, hasn't it? It's gone soft and horrible. Anyway, let's get this movement working right. You want to zero it, and you're going to need a digital meter for the purpose of calibration. Got to be fairly careful now because of course there is no protection on this meter at all anymore. So I'm going to put this meter 300 microamp range, beg your pardon. Going to up the resistance substitution box to 100k and put it on 2 volts and it's just swinging around. Believe it or not, I'm not using a Fluke digital meter. I'm actually using an AVO to calibrate it with. Get it all there so you can see it. Right. When this is drawing 37.5 microamps, what you should have is full scale deflection. And it's swinging around at the moment because I haven't got a very good connection on here. Okay, so we've got in there 100k and 2 volts on the power supply, and we're just going to keep an eye on these figures here. We want that to go up to 37.5 microamps. Just taking it up now. .5 microamps. If I do the eyeball on the range with the mirror, it's bang on full deflection. Full deflection is use the ohms range, it's the 0 on the ohms range and it's the 10 on the top range, because there are two markers after the 10. Yeah, that's tickety boo. That's bang on. Right. The next thing you need to do is 37.5 divided by 2 equals 18.75. It's as close as I can get, and that is of course half the value of 37.5 microamps, which means you should have half scale deflection. This is for the linearity of the meter, and I'm just zeroing that by eye, and I'm perfectly happy that that is there. Slightly under the 5, which nothing at all to worry about. You can go further with this if you want to and go down, but if you've got full scale deflection and you've got half scale, then you pretty much got it there. That's it. Just turn this off a minute. Check our 0 again. Okay, so once you can say that you've definitely got an accurate meter movement of 100% and 50% on 37.5 microamps, the rest of the meter will just fall into line. Unless there's something burnt out or completely buggered somewhere, it will just be right. You can get this movement, put it in this meter, that meter, this meter, that meter, and it always gives you the same results. So I can be quite satisfied and quite happy that this meter movement is okay. Although I'm not so happy about the cutout, I'm afraid. I'm just going to give that a little bit of thought, and because I'm pretty sure I haven't got a spare one, but never mind, it's still a usable meter even without the cutout in there. It's just I don't like things unless they're right. Okay, so we've covered all the meter movement itself, and its deflection rates, its amounts of current that it draws, and this is a Mk5, and but they're all pretty much the same. 37.5 microamps on the AVOs. You'll find that in any of the service manuals, and I forget what it is now, but 333,000 ohms per volt or something. I don't know, I'm not sure. All I'm interested in is in the current rating. Anyway, I'm going to just stop this video for a minute and have a little play with this reset, see what can be done and what can't be done. I'm just wondering if there's anything I can make out of it. I'll start it up when we slap it all back together, when we clean them pots out, because you have to drill holes in those pots. I've shown you that before. I'll show you it again, because if you drill a hole in the wrong place, you bugger it completely. Right, I'll just stop this now. Well, that was good. That was the wrong button. Oh God, I will get used to this thing, I'm sure. But oh, it's on the side there. Just before I start messing around with it, I just thought I'd say that now is the time when you want to clean this scale because you won't get opportunity again. So just undo these brass washers on the back of these screws. Clean the white scale with just a little bit of foam cleaner. Don't rub it like mad or anything, just clean it over gently and slip this off, and that gives you full access to the actual, if you can see that line, look in it. It's you read for the parallax error. A little bit of glass cleaner and clean that up. And remember that the mirrored surface is not at the back, is actually, this is the mirrored surface, because otherwise you'd have parallax error through the glass. So when you clean it, a little bit of glass cleaner or vinegar, and treat it with the respect it deserves again. Then bolt it back together, and there will be some movement on this, but don't worry, because once you've zeroed it, your full scale deflection will still be at 37.5 microamps. So if you put it back in, say there, over that side, as soon as you zero the needle, your full deflection will be 37.5. It's pretty bulletproof. You know, the accuracy of it is pretty straightforward. Anyway, I'm going to stop this now. I'm going to have a look at this this protection, see if there's anything I can do with it at all. Right, before I start mucking around with this too much, and I'm pretty sure I can fudge a way to make this work, but it's got to be done in a respectable way, and it's got to be done in a way that lasts. However, look, this is a view through the magnifying glass and light, because I thought it might be interesting to see. This is the reset pin, like that, and this is where we fire it off. You can see just through this hole there's a little latch goes up and then rests on there, and we'll just fire it off, and there it is. That's how your sensitivity is gained. And you've got this half is for one side of the meter movement, and this is the other side of the meter movement. When you reset it, and that centre pin here this centre pin here, this black pin, will sit on this centre post. So we push it in and let go, and it sits on that post. Now I'll just trigger it, push it in again, it goes on that post. It's very clever, you know, it's very nice and enjoyable. All I've got to do basically is figure a way of this cam that goes down here, sprung loaded cam, from being on to its off position, to somehow come out and rest a bar across these two terminals. And these will basically, they have to be able to carry 10 amps just for the 10 amp range. Obviously it shuts down everything when it fires off, but it must carry a minimum of 10 amps, and the bar that goes across it, where are we, here it is, and here's the bar, goes across there. It will easily carry 10 amps, but I don't know if you can see the absolute bloody carnage that was the switch. It's just, the plastic's just disintegrated, and there's nothing I can do with that, nothing at all. So I'm thinking along the lines of some sort of PCB, and maybe have to do a little bit of artwork on it or something. But I'll turn this off for now, and because it's going to take me a few hours to figure this out, and I'll get back to you. Right, now I'm only going to show you this if you promise not to laugh. I've done the best I can. Right, what I've done is, you've got the trigger bar here, which is all one long bar with a couple of springs on. Here's a trigger bar with a couple of springs on. I ground a flat edge on it there, down here, and I drilled a hole through it. I tapped the hole and then put a nylon screw into there, offering insulation from the trigger bar. Then I put a piece of PCB with the switch contacts mounted on it here, drilled a hole, you can just about see it, through the bottom there of the switch contacts, put a self-tapping screw in, which screws into this nylon screw. This nylon screw does two things. It holds it, and it can't turn because of it's in place with the PCB there. Your contacts are there, so they're still exactly the same as they were, and the elasticity in the nylon screw puts the contacts down. So if we push it down, it makes contacts, and it's very firm as well. Then we break it, put it down, break it, put it down. Now there are without doubt hundreds of engineers out there that would just say, oh my god, I could do such a better job than that. Well, I'm sure you could. I've just done the best I can, and if you look at it sideways on there, you'll see the bend in this nylon screw. See that? It's quite a bend. It's quite a lot of pressure on the contacts. And I'd be more than happy to say that they're still going to take their 10 amps. So that's the best I could do, and it saves this meter. And let's face it, every single one of these are handmade, and they're all slightly different. But I'm going to put that back together. Because I've been grinding and cutting and drilling and tapping, I took the meter movement away and I stuck it in a plastic bag so it wouldn't get contaminated with anything. Since then, everything's been hoovered down, it's been wiped down, and it's been foam cleaned down, so there is no metal bits and pieces around here now. So I'm going to get this, I'm going to stick this back in the meter movement, and then I'll come back to you then, because we've only got the meter movement to install, and then just to drill those pots and squirt a bit of switch cleaner in them, and we're away. Right, hold on. Right, just one more thing to mention about this meter movement. There is a weight down here. It's the opposite end to the needle. It's purely just to counterbalance the needle. Full scale deflection should be about 1 second. To reach it. The other thing you've got to do is, with it in a horizontal position, set the forks vertical like that, and if you haven't got zero there, then you must zero it on the back fork. Well, it's not a fork, it's just a solder terminal. There we are. So now when you turn it on the front, you'll have about 3 notches forward and 3 notches behind zero. But that's our meter movement. It's all cleaned. If you do find yourself in a position where you need to lubricate these the 2 needle bearings on the movement, don't be tempted to use WD-40 or a Servicing oil or anything like that. Use ordinary lighter fuel, just a little tiny drop of lighter fuel, not even a drop, it's a smidgen, and that will dry off instantly, more or less instantly, but it will leave a very, very fine film of oil, which is exactly what you want to use. It's what they use in watchmakers. Watchmakers use it a lot to lubricate things, so that's what you want to do. I've put this all together, so we can hit reset, give it a blow, and it pops up. Hit reset, give it a blow the other way, and it pops up. Oops, just realised you can't see any of that. I'll do it again. Push reset in. And there it is. So it's just as fast as it was. It's as good as it was. It's not as pretty as it was, but what can I say? I'm an electronics engineer, not a mechanical engineer. I'm sure a lot of people could do it a lot better, but it's as good as I can do. Anyway, let's get this thing stuck in. I've cleaned the front, I've cleaned the glass, the shroud and that, and I zeroed the pin earlier on, so that's already in a nice low position. So what we're going to do now is put some washers on. Let's try and get this in view. Big washer goes there. Big washer goes there. And there was one little spring wash missing, but I had a spare, so we'll put it in. That goes there. And of course there. Switches are fully out. These 2 switches, but they're always a little bit of a pain to get them to fit on, but there we are. That's all closed up. I'll actually put that back on it now, just so that it stays. So these damn things break away all the time. Just want to check there's nothing in there from that blue switch. No, there's nothing left in there. No, that's fine. Just get that on there. Anything closed and nice and tidy with that little mod in there. Oh dear, the things we do for AVOs. Right, offer it over the hole, so it should go over the switches. There we go. The brass one's in the top first. one. Don't over tighten them. That's it. Make sure that it all looks okay at the front. And this should be able to just push the cutout in. When the cutout's not in, you can't get a proper deflection below 0. There it is, swinging about like a good one. We'll worry about the rest of that in a minute. Okay, super duper. What we're going to do now is these pots, one of which we've actually taken out. There it is, and I'll go through it with one of them, so that once you've seen one of them, they're all the same. Okay, as you can see on the back, you've got a triangle. Very definite. I'll just get in there a bit. Very definite triangle. Like you can see, so this is the wiper, which is linked to one of the ends of the strips. And this is the other end of the strip. So now we know where the strip of carbon goes around like that. So you just look at the centre line from here. Just go straight down, and make a little mark. Stick the pot somewhere in the centre, doesn't matter where, just as long as it's not sitting at the edge, just in case you hit it. Get your Dremel out. You want a 1mm drill for this. I've been messing around with 1/2 mils and all sorts today, doing that switch thing, that breaker. So we'll just put a 1mm in there. Okay, move the meter out of the way because we don't want any shards, although it's only aluminium, but we don't want any shards going in it. There's our marker. Quite thick aluminium actually. That's it. Go through. Good old Servicing, just add ordinary Servicing switch cleaner. switch cleaner and lubricant. Get some in there, give it a wind. Give it one more spray. Lovely. Put the adapter plate on. It's got a little location on it, so it'll only go one way. Nip it up. We'll bring our meter down just to get rid of these shards of aluminium, although nothing should go anywhere near it now. Drop it into place. With 2 screws that hold it in. That's all you got to do with that. Now the other 2 are screwed in the pot, screwed in the board here. I won't bore the pants off of you, but all you do is you just unsolder them, unscrew them, drill them, spray them, put them back. That's all you've got to do. So I'll do that now. Actually, I'll leave the camera running, and I'll just speed the video up when I edit it. quick screw it round with the best service hole on the bottom sets contacts. Give them a couple of twists. Okay. I'm going to start off by putting the top in because I've still got a little bit of work to do on the switches down here. This is our 10 amp wire. Well, it doesn't just do 10 amps. I mean, that's very misleading. It does the whole range. The whole range goes through it, but it's got to be capable of 10 amps because it's a 10. You've got 10 amps on the meter. Right, just a little thing, when you put these caps on, there is a bit of plastic sticking out on them. It's not just where they've roughly, cut it off. The idea of it is that when you put your high voltage resistors on it, that wire should be located under the so you push it down and you give it a turn like that before you nip it up. The wire that is underneath that little bit of plastic. Same applies to this side. Tighten the earth tab up, bend it up so that it's not touching that resistor. Right, okay, just get a duster or a piece of paper towel or whatever you got, some isopropylene alcohol, and just make sure these tracks are nice and clean. Do them on both sides of the board. Okay, that is the right grease to use. Servicing silicone grease. High electrical installation, waterproof, repels moisture, excellent lubricant, high temperature resistant. What else could you ask for? I'll do the underneath side of it first. A little tiny blob on my finger. If you put so much on that you fill up all these holes in the PCB, you're putting too much on. About that much. Also make the switches feel very nice. Do the B side. Right, that's it. The only thing you got to do now is stick that PCB back in, solder the middle potentiometer in for 0 in the ohms range, and connect the meter movement up, connect the terminals up, the post terminals that is, and you're away. So let's first of all get these switches lined up and in place. Somewhere about there. These two pot slots should line up and go through the front fascia. There we go. And the two wires from the pot that screw to the front, they should just pop up through the plastic circuit board, which I've already put them through that, and then pop them through the hole in the PCB. And they do matter if you get them the wrong way round, because otherwise they zero the wrong way round. You know, instead of turning it clockwise for the needle to go clockwise, it will do the reverse. I know it's obvious, but whoops, just remember it when you're taking it apart. I marked one of the terminals so that I bloody thing. There we go, got it. Right, super duper. Right, there's the one that I marked. so with a bit of red coming a little bit. With a little bit of red, and the wire, I just put a little bit of a solder mark on it, so it's that wire. Terminal posts, lower caps. The black earth wire that I unsoldered earlier, I've already soldered that on. Make sure this wire's just tucked into that little cutout on the board there. And whilst I remember, don't forget your little plastic nylon screw there. It's got a different sort of spacer underneath, but I'm sure you know that anyway. Done. Make sure they're tidy. They are. Right, here's your meter movement wires. We stripped them back earlier on because we used them to check our full scale deflection, so we can just tin them. Right, thread them through the blue PCB so that they go up through by the switches. This video hasn't been about repairs, it's purely just been a case of servicing, apart from of course the isolation breaker that was broken. This is just the meter movements going in, two wires. One to go. Make sure that they don't foul on the switches when the switches are rotated, because that one would. No problems there. I know it's not very professional using a pair of pliers, but my nut runner's gone, so I've got one on order and it's just not here yet. Tighten up your terminal posts. Going to need 2 tie wraps, one small, one big. Small one goes through here and just hooks up the wires that go to the batteries. Large one takes up the wires that go onto the terminal post. Okay. Just a case of connecting the batteries now. Look at the front of it. Oh, the rubber on this switch is a bit fubard, I'm afraid. See if there's any splits on these knobs. If they do split, just put a bit of wire around the outside of them, otherwise you'd lose them, and as I'm finding out, they're not easy to get hold of. Right, quick look inside just to make sure that you've got nothing running into these switches. Nope, nothing running into those switches. Right, I'm going to put that one aside for a minute because this one's got a little bit of corrosion in the... I'll show you the little bit of corrosion just there. So we'll just whip that fuse out. Fuse? It's not a fuse, it's a standard 1 amp precision fuse. Precision fuse. Will be. Turn it over, push these posts out, and that's it, it's out. And you just clean it up and put it back in. Some people just sandpaper it, other people just use a wire brush on it. What I'm going to do is I'm just going to go and just take in the kitchen and stick it in a cup of Diet Coke, and that usually cleans up quite nicely. Right, just going to pause up there for a bit. Okay, I've screwed it all together and put a couple of batteries in it. And that's the right battery, but to make up for the battery, yeah, I've just put these 3 volt lithium cells in there. 3, 6, 9, 12, 15, so 15 volts, and just packed it out with a, actually that's a capstan, piece of a capstan. Stick a bit of draft excluder in it, and that'll do. I mean, I will obviously you put the right. I will put the right batteries in it, but this will do just to get it going. And here we have it. All singing and dancing, hopefully. We'll just get a DC power supply. Put it on down to 3 volts. That'll do. Check our 0. That looks fine to me. Circuit breaker's obviously working alright. 3 volts, that's good. Stick it on a 10 volt range. It still says 3. Increase it to 10 volts. Looks like 10 to me. Stick on a 30 volt range. 30, 20, 10, that's 10. Stick it up to 30 volts. 30 volts, oh, what's 31? 30 volts. 100 volt range. That's 30 volts. I can't go up to 100 volts, but I can go up to 60. 60 volts. 300 volts range. 10, 20, 30, 40, 50, 60 volts, 600 volt range. Three, 600 volts, where are we? 6, that's 3 and 6, that's 2, so it's double that scale. So that's 246, 60 volts, and 1K range. Just a bit harder to read, that's all okay anyway, no problems there. Just try quickly a couple of resistors on it, because after all all we've covered in this video is extensively the meter movement and how to check it and calibrate it and how to weight it if it needs weighting, and basically do everything that AVO used to do to them. Stick this on the ohms range times 1. Well, that's lovely and smooth now. Range times 100. Lovely. Times 10k. Super duper. Times 1. High 1k. Well, that's going to be hard to read actually. Okay, I'll put in there 10 ohms. 10 ohms, that's fine. 20 ohms, that's fine. 30 ohms. And 40 ohms, that would do to prove that. We've already zeroed this, we'll do that in a minute. And this is times 100. High. So that's 10k, which it would be. That's 10k. Take it up to times 10k. It's on the first mark, which is 10k, 20k. So we look at 100k, 200k, 300k. Okay, so there we are. So this will happy that it's doing this thing. Take this off. Our protection works, and the reverse Mac works. So the actual unit is finished. So we've extensively looked at the meter movement, how to calibrate it, how to check it, how to weight it, balance it, and do everything you need to do to it. We've also covered switches, cleaning and lubrication, and we've also covered the pots, which is just a case of drilling them out and put a bit of cleaner in them. So we've covered the basic strip down and assembly. So we haven't actually done any fault finding, but apart from the circuit breaker. But there's nothing else to do. This meter's out the door now, so it's actually I'm not even sure what I'll do with this one. I might even just use this one as spares, because although that breaker's there, I'm just not. I'm not 100% happy with it. But anyway, that's this blog, and we're all finished up. And I hope you enjoyed it. I hope you got something out of it, and we'll see you with the next one.